6th grade. Today we're going to be beginning our new unit on geometry. So the first section that we're going to deal with is about finding area of quadrilaterals. To begin, there's an explore activity, which we don't always do, but I like this one. So what I want you guys to do is I want you to follow all these steps and complete this explore activity on your own. Because what it's going to do is it's going to actually derive the area of the parallelogram for you. Okay, so all you need is a pair of scissors. You need, if you have graph paper, if you don't have graph paper, you can print it out from online. There's online graphing paper, and then you just follow these steps. All right, so when you come back, we'll take a look. Okay guys, so if you follow the steps, you draw a parallelogram on your grid paper and you cut it out, and then you cut off the height. From the height down, you get this little triangle. And what you're supposed to do is take this and then place it on the other side. And see what shape you get. And as you can see, the parallelogram forms a rectangle. So if you fill out all those blanks, you're seeing that the base of the parallelogram is the same as the length of the rectangle, and the height of our parallelogram is the same as the width of our rectangle. So when we find the area of the rectangle, where we're normally doing length times width, we're doing base times height of the parallelogram. So they have the exact same formula, but instead of using length times width, we use base times height. Okay, so that's written here for you. The only difference is that we, instead of calling it length times width, we do base times height because a parallelogram is sometimes diagonal like this. So the height is from the top straight down to the bottom. That forms a right angle. So this is called being perpendicular, right? So your height can be drawn from the top straight down, forming a right angle. So if you're given a length for this piece here, that's not your height, okay? The height is straight down. It looks like a triangle once it's formed, okay? So to find the area of a parallelogram, you're doing base times the height. Okay, so let's look at what this actually looks like. As you can see, our height is labeled. It looks like a triangle. This is your H. Your base is 14. So to find the area of the parallelogram, we're just doing base times height. So what I like to do is I always write my formula, and then I write B equals H equals, and you guys probably remember this from last year when we did geometry at the end of the year, and everything gets labeled. So the base is 14, so B equals 14. The height is 7, so H equals 7. And then I just find this answer. So we're plugging it into our formula of base times height. So instead of B, I write 14. And instead of height, I write 7. So base times height, 14 times 7. That's going to give me 98. Now the one thing I need to remember are my units. Units are important. This is going to be centimeters, and area is always squared. So it's going to be 98 centimeters squared. Really quick off to the side, the reason why your units are squared, when we're doing base times height, we're doing 14 centimeters times 7 centimeters, okay? So we're doing 14 times 7, which is the 98, and then we're doing centimeters times centimeters, which gives me centimeters squared, okay? Next, we're going to look at how to find the area of a trapezoid. This is a way more complicated formula to use, but it's very straightforward as long as you know what each of those variables represents. So when we have a trapezoid, it's a funny looking shape. Usually it looks like this, okay? And you can actually form a rectangle out of it, parallelogram out of it by taking the trapezoid and then flipping it over and putting it next to it. So they fit together to form a parallelogram. And so for that reason, the area of the trapezoid is a half of the area of the parallelogram. So that would be half of the base times the height. However, we have two different bases for a trapezoid. So instead of doing 1/2 base times height, we're doing 1/2 of the two bases added together, right? Because we have base this base and that base added together, okay? So you don't have to memorize this, so I wouldn't worry about understanding it, but I do always want to show you where the formula comes from. So the area formula is to take 1/2 times the height, and in parentheses we add the two bases together, base 1 plus base 2. So when you're doing this, you want to follow PEMDAS, right? So we're always going to add the two bases together, and then we're going to do, if it's easier to do 1/2 of the height first, and then multiply it by what you get inside, you can. If it's easier to do the height times the bases and then do 1/2, then you can do it that way, because multiplication is commutative. You can do it either way. So just quickly, I'm gonna walk you through this. We have this trapezoid. The height is 16, the first base is 17, and the second base is 39. So this is all done for us. I'm gonna just do it down here. So the area is equal to 1/2 of the height times base 1 plus base 2. So what I do is I always label all my variables first. The height is 16. Base 1 and base 2, it doesn't matter which one you pick because this addition is commutative, but I said base 1 was 17, base 2 is 39. And now I'm just going to plug everything in. So the area is going to be 1/2. The height is 16 times base 1 plus base 2. That's going to be 17 plus 39. So before I do anything else, even though I have this 1/2 of 16 here, I do want to add these two together, which is going to give me 56. Okay, and now you can do whatever you prefer. In this case, it'll be easier for me to take 1/2 of 16 first, because I know that that's 8 times 56, but if you want to do 56 times 16 and then take 1/2 of that, you can. Okay, and now you can do it off to the side if you need to. I'll show it all the way out. 8 times 6 is 48, carry the 4, and then 8 times 5 is 40, plus 4 is 44. So the area is 448, and it was feet, so it's going to be feet squared. Area units are always squared. Okay? You can also write square feet, just so you know. I like to keep it this way though. Okay? The last thing we're going to learn is how to find the area of a rhombus. Okay? So in a rhombus, all the sides are congruent and the opposite sides are parallel. So that could be a square, but it also might not be a square. It's a tilted sort of square. So, I mean, a square is congruent sides and opposite sides are parallel. So I shouldn't have said that it might not be a square, but a square is always a rhombus is what I'm trying to say. Okay, so it's almost like a square, but then it just got tilted diagonally. But if you have a regular square like this, that's also a rhombus. Okay, so if you took all these triangles, you could rearrange them and they would form another rectangle. And so the area ends up being the base times the height still, but the base is the first diagonal times 1/2 of the second diagonal. So to find the area, what the formula we use is 1/2 of diagonal 1 times diagonal 2. Okay? So you just multiply the length of the two diagonals together and then take 1/2 of that. Okay? It looks complicated, but wait till you see how easy it is. Okay? So we have a kite here, and that's going to be like the #1 example you see with the rhombus is a kite. Okay? You're going to have two diagonals. So this is my rhombus. This is one diagonal, it's 15 inches, and the other one is 24. So the area is, again, 1/2 diagonal 1 times diagonal 2. So I label everything. Diagonal 1, we'll say is 15 inches, and diagonal 2 is the 24 inches. So all I'm doing is multiplying these together and then taking 1/2 of that, or dividing it by 2. So 1/2 of 15 times 24. Now you can multiply these two together and then divide by 2, but I'm going to do something different. I'm going to do 1/2 of 24, because that's going to be 12, and it's going to be much easier for me to do 15 times 12. Alright? You don't have to do it that way. I'm going to just multiply this. So this is 10, 3, 5, 1, which which gives me 180. So the area is 180 inches squared. It's a lot easier than it looked, right? So you do the your turn on your own, pause it, and then check your answers. All right, so here's the solutions. So I used the 1/2 trick for all of them. The last one was a little bit involved, but you can do that one whichever way you prefer. So for number 3, I got 210. I did half of 12 and then multiplied that by 35. Number 4, 66.5. Did half of 7 and multiplied that by 9.5. Number 5, got 90. That one was super easy. I took half of 18 and then it was just 9 times 10. And then for number 6, that was the trickier one. You could choose which way you'd like to do this. I chose to do half of 40 and then multiply 20 times 8 1/4. You could change that into a decimal if you'd rather, or you could do half of 8 1/4 if you'd rather, whatever you want, but you end up with 165. Okay, so I know this is kind of seems like very complicated, but it's all just plugging in. So whenever you have formulas, you just plug in the numbers. Don't let it trick you. Don't let it get more complicated than that. You follow the order using PEMDAS. Okay, and that's all there is to it. And you don't have to remember any formulas. You write them down, you use them. So for a rhombus, it's 1/2 the diagonal times the other diagonal. For a trapezoid, it's 1/2 height times base 1 plus base 2. And the area of a parallelogram is just base times height. Okay, so that's all you need to know, guys. You can use that on your homework. You don't have to memorize them. Okay, have fun.